Okay, so basically your project assignment is more on the MOSFET scaling. Okay, MOSFET scaling. If you can see from here, okay, so it covered on the CLO5, okay, to articulate and communicate latest development in the field of semiconductor device engineering, project-based learning. So I will use as a simulation lah, basically. Okay, simulation. Okay, so the objective is of this assignment to simulate N-channel MOSFET device structure, okay, by using open source simulator and do characterization. Okay, what is I think this is quite a benefit for all of you, okay, because you already took the lab, okay, where you use Centaurus for the same kind of simulation. Okay. However, that one you design the N-channel MOSFET and then you simulate the IV characteristic and then you characterize what happened, this and that. Okay. So for this assessment is more structured. Okay. You don't have to design. Okay. You just have to simulate and then you analyze or discuss the characterization. Okay, the task must be done in a group of 4 to 5. Okay, the one that I showed you over here, but still not full yet. Okay, maybe you have forgotten the link or whatever. So I will be sharing the link again so that you can fill up. Okay, and then in appendix 1. Based on the appendix 1, simulate the MOSFET device structure by using MOSFET simulator. I'll be using nanohub.org. So this is the link. Okay, after this, I will show a little bit of overview on how to use this Nanohub open simulator. Before you can use the simulator, you need to sign up first. Okay. Okay, and then you simulate the N-channel MOSFET and then fill up the device parameter according to the task given. Okay, so this is what it meant. Okay, so you will be simulating your MOSFET structure by using these, what I mentioned, the dimensions. Okay, the dimension is based on this figure and also this table. Okay, this figure and also this table. So everything I have given here, okay, the dimensions of the gate length, dimension of the oxide thickness, the width of the substrate and so on. So you have to follow all the dimension here, including the concentration, okay, including the doping concentration, to of 20 and so on. Over here you have to follow. Okay. All right, what's next? Okay, after you follow that one, okay, you simulate. Okay, you simulate and you obtain the IV characteristic. Okay, in Nanohub, you will be able to get the IV characteristic of IDVG as well as the IDVD. So those IV characteristics, okay, you can extract from the simulation. However, your job is to find the surface charge. Okay, since you have learned the surface charge potential quite a lot, so your discussion must be related to the surface charge. Okay, the electrical properties of threshold voltage, I-on, I-off, DIV, and subthreshold strength. These things you have seen in the lab. Okay, however, you're going to do it again now. Okay, although you have done the lab, I also define what are those things. Okay, so for example, threshold voltage is defined as the is equal to the VG at ID equal 10 to the power of -6 and so on. So these are the definitions. Okay, so you're going to plot for both. Okay, at linear region when VD equal to 0.05 and at saturation when VD equal to 1 volt. All right, so your report, okay, handwritten is not accepted. Okay, your report must be not more than 10 pages. Okay, standard formatting. I will provide the template for report. Okay, you can follow the report template later. So it must include introduction, simulation results, the discussion, and also the conclusion. Okay, a group recorded presentation. Okay, PowerPoint not more than 15 minutes. Okay, I will okay, there will be two types. Okay, it's either live presentation or recorded. Okay, you can choose either one. However, I will be playing the video during class time. Okay, and I will watch together with all of you. Okay, the video recorded, or you can present live as well, but not more than 15 minutes. Okay, after end of the recorded session or after end of your presentation, live presentation, I will ask question. Okay, not more question, maybe one or two question from the each group. Okay, so must be submitted before 19th of January. Okay, so report must be submitted on 26th of January. That is the latest lah. Okay, basically. Okay, so you can choose either one. You can record your presentation or you can also live presentation. Up to you. You can discuss in your group. Okay. Okay, so this is the appendix, all right? So this is the appendix. So basically, you read blah, blah, blah here. Okay, and this project assignment, you are required to simulate 3 generations, okay? 3 generation of gate length. So from here, you already get the idea. So basically, it is about the short channel effects, okay? So this is the main, okay, the main structure. Okay, now you have to vary 3 channel lengths. Okay, so first channel length 50, second 40, third is 30. So which one is channel length? So this one between source to drain. So this 50 is actually defined the channel length. So you have to vary this. Okay. However, the rest of the parameter will be the same. Okay. The only difference is the channel length. So you discuss the difference or your observation. Okay. So find the electrical properties for each devices. Okay. From your observation, device 3, okay, you may get a slightly different of IV characteristic of the device 3. So what are the different? I think you have learned in the class, okay? You have learned this in the class. So there might be a difference of these things. So what are phenomena that cause device 3 behave differently? So you have to discuss this, okay? All right, the second one, so that is the first part. So the second part is this one. Okay. Previously, the first part, the gate electrode is N plus polysilicon. Okay. So all for 3 devices must be N plus polysilicon. Okay. You don't change it. You just fix with the N plus polysilicon. Okay. However, for the part 2 of your assignment, you might have to change. Okay. You stick with the device 3. However, the gate electrode now changed to metal, tungsten, aluminium, and molybdenum. Okay, so what are the difference between these? You know, it is the metal work function difference since the type of material difference, tungsten, aluminum, and molybdenum. Therefore, the work function also different. So your discussion must be in terms of the work functions difference. Okay, so you observe between the 3 difference of this gate electrode. What is your observation? So you discuss your results from here. Okay. All right. In appendix 2, if you want to get a full mark, okay, for the report writing, you have to follow everything over here. Okay, I have provide the rubrics, okay, and presentation also you have to follow this rubric if you want to get a full mark. Okay, like I said, this is I may say this a bonus mark for you. Okay, I will not be very strict. Okay, however, if you put your effort and then I already give you 2 weeks free towards the end of the class, you can fully utilize during class time to do the simulation and discuss with your group. Okay, definitely you can get as high as 18 marks or 19 marks. Okay. All right. Do you have any question from here? If not, that I want to show you the open source simulator. Do you have any question, guys, girls? Clear on the part 1 and also on the part 2 of the simulation?
Clear होता है.
All right. Very good. Okay. So let's see the simulator. Okay. Okay. So you go. Wait. You go to this link. Okay. Okay, follow this link. Okay, like I will copy this link. Okay, but before that, okay, you need to sign up. Okay, please sign up to the Nanohub. Okay, later you can sign up. Okay, go to this link. All right. Okay, all right. So since I already have account, so it's logged in automatically. So this is how it looks like. Okay, this is how it looks like for the simulator. Okay, so if you want to use so this simulator is open source and it is quite recent, has been published in 2017. Okay, and very reliable to use. Okay, and also there is a lot of notes that you can find for your reference. Okay, for example, you can click over here at the supporting documents. Okay, there is a note on the user guide, on the video demo, and also learning materials as well. Okay, yeah, you can take a look here later. Okay, however, I will show you how to launch the tools. Okay, so click launch over here. Click launch. It may take some time, however, not as long as Centaurus. Okay, it is doable. No worries. Okay. All right. So this is how it looks like. Okay. This is how it looks like for the simulator. So basically, you have to put all the input inside this simulator, and this simulator will run your simulation. Okay. So if I put side by side over here, I hope it is not too small because this way is more effective. Okay, little bit smaller here. All right. Okay. Okay, so you're going to simulate this one. Okay, this one. Okay, so for the n type case, for the n type, if you look at these structural properties, there are three tabs: structural properties, model, and also voltage sweep. Okay, so look at here for the structural properties. Okay, since the device type has many type. Okay, so for this one, if you click here, it will scroll down many type of device structure. For your case is a MOSFET n-type. Okay, this one, MOSFET n-type. Normal one. For the doping profile, we're not going to use the Gaussian and so on. We just use what we have learned in class, which is uniformly doping. Okay, this one. All right. So for example, let's simulate the device one. Okay, device one, 50 nanometer gate length. Okay, 50 nanometer gate length. So in here, source drain length. So where is source drain length? Here. Okay, source drain length is here. This line, which is 50 nanometer. Oh, this one also 50 nanometer. Okay, let it be. Okay, and nodes, let it be as by default 15. Okay, gate length, okay, channel length, this is 100 nanometer, but the one for device one that I want you to simulate is 50 nanometer. So 50 nanometer. So you may change this to 50 and then enter. 50 nanometer. Channel nodes, let it be as fixed as this one. Okay. For the oxide thickness, okay, 1 nanometer over here. I have written in the word file here 1 nanometer. So change to 1 nanometer. Okay, and then for the junction depth, okay, junction depth is this one 24 nanometer. So this is the junction depth of source and drain, and this is the substrate thickness 76. Okay, junction depth is 24. Okay, and then substrate thickness is 76. Okay, all right. The nodes, just let it be like that. Okay, for the device width, also make it 1000 nanometer. Doesn't matter. Okay, and then this is the physical dimension. Okay, how about the parameter concentration? You scroll down over here. You can see the concentrations. Okay, for the source drain doping concentration, 2 times 10 to the power of 20. Okay, for the channel doping concentration, it is 1 times 10 to the power of 19, not 18, 19. Okay, and then the substrate doping also 19, 1 times 10 to the power of 19. 1E19. All right. Okay. Okay. So now what else? So gate electrode is N plus polysilicon. Where to change the gate electrode? You go to the model tab over here. Okay. So gate electrode, as you can see over here, if you scroll down, there are many type of gate electrode. Okay. So for this case, N plus polysilicon. Okay. The rest for the part 2, okay, you have to change tungsten, aluminum, molybdenum. So you just change it from here. Okay. If there is aluminum, there is tungsten, however, molybdenum, no list in the list. Okay, you can specify work function. You can click work function over here. You can specify the work function. Okay, so what is the work function? You need to check for molybdenum. How much is the work function? Okay, so you put the value over here. Okay, all right. So let's go back to the N plus polysilicon. All right, that's it. Okay, now you want to run. Okay, go to the voltage sweep. Click here. Did I started recording? Yes. Yeah. Okay. All right. So there are two plots. Okay, IDVG plot over here, and the second one is IDVD plot. Okay, you might have to plot both. Okay, so click yes over here. Okay, the rest over here you don't have to click anything. Just let it be by default. Okay, so yeah, that's it. Now you ready to simulate. Okay, click simulate over here. It may take some time, depends on your internet connection. Okay. However, not okay. For my case, it is quite fast because I have run so many times before. Okay, and it's already saved. Okay, for your if your first time, it may take some time lah for all of you. Okay, I make it bigger a little bit. All right. Okay. So from here, so this is the IDVD characteristic. Okay, IDVD characteristic. Okay. For the report, usually previous student will replot again. Instead of you capture the figure over here, you can replot. Okay. So where is the IDVG? Okay. So you can scroll down over here. There is an option IDVG. Yeah, so this is the IDVG. Okay, so you can get the data and you can replot by using Excel or MATLAB. Okay, previous student they plotted using MATLAB, Excel, up to you. Okay, so how to get the data? You click arrow down over here. Okay, arrow down, and you can also download the image. And you can also download the data. Okay, means the data means each of the point over here, the VG point and ID point. You click download. Okay, and it will automatically download it, save to your. So this is in the notepad, but you can open by using Excel. Okay, you can open by using Excel. Okay, you open with Excel, right? Okay, so that's it. Okay, so that is for the IDVG and also the IDVD. So you need to analyze. Therefore, I suggest you to replot again somewhere. Okay, and so that you can make comparison between device 1, device 2, and device 3. Okay, so what else needed is other than IV characteristic. Okay, IV characteristic. So both IDVG and IDVD characteristic are needed over here. And the other one is the surface charge plots. Okay, surface charge plot. So this is your part as well. So you may get the surface charge plot over here. Okay, click here. So this is the surface charge plot. Okay, so basically this is the surface charge plot along the channel. Okay, you might have to discuss this. Why? Okay, at VG increase, the surface also increase. So you have learned this. So now is for you to apply. Okay, to apply. Okay, okay, to apply what you have learned. Okay, whatever, but do not put a lot lah in the report, not more than 10 pages. Okay, all right. So for the, I go back to the IDVG. So there are two lines over here. What are the difference of these two lines? So you have two VD bias. So from here, if you can see, so this is at linear region, this is at saturation region. So you might have to define which is linear region and which is a saturation region. So the red one is the saturation region. The blue line is the linear region. Right, so all this you can download the data. All right, so yeah, so that is for the first part. For the second part, okay, same. Okay, same. However, you have to change the gate electrode. Okay, where to change the gate electrode is in the model here. Here. Okay. All right. I think I have explained everything. Okay, if you have any question, you can always ask from time to time, especially okay when we finish our lecture and you will use your time okay to simulate. Okay, that time you can ask from time to time. Okay. All right, so I actually prepare some platform. Okay, that platform is for all of you to update your progress from time to time. Okay, so since this project is divided into two, you have one part is the device scaling, the other part is on the gate electrode this difference. Okay, so you may have to discuss part by part. Okay, I will prepare by using Trello. So Trello is a web-based application. So that is where you will discuss everything in the group lah. So I will monitor from there. Okay, but not finished yet preparing the Trello, but I will post it later. Okay, basically today I will just explain what is your assignment all about and also how to use the open source simulator. All right, do you all clear? It's very much clear. Are you all still there? Hello?
Yup,
All right,
clear tu.
very clear. Okay, so I think cannot